Hello everyone, happy to see you here. Welcome back to my channel. Hi, I'm Mathematics. Today we have great, quick and relaxing algebra question. We know that 3 to the power t equal to t to the power a, and we need to solve this equation for t. So if you have your solution, your assumption, your notes about this question, write it in the comments below. It will be really interesting to read about it, and of course it will be really interesting to check our answers in the end of the video. So 3 to the power t equal to t to the power 9. So let's start. First of all, I want to rewrite this question. So 3 to the power t equal to t to the power 9. And the first step right here, I just want to split. So I want to write our variables on the left side and our constant on the right side. So how can we do this? I want to raise both sides to the power 1 over 9. This is our first step. So let's do it. So 3 to the power t raised to the power 1 over 9 equal to t to the power 9 raised to the power 1 over 9. Really good. And right now we need to learn about really interesting property. This property looks like that. Everyone knows about this property. When we have a to the power x, when we raise this to the power y, we can write it as a to the power x times y. So that's why we're going to multiply our powers. So let's do it. So we have 3 to the power t times 1 over 9 equal to t to the power 9 times 1 over 9. So really good. And right now we can easily cancel this 9 on the right side. So we have only t, and on the left side we have t over 9. And the next step, I just want to change this thing position. So I want to write this thing t on the left side. So we have t equal to, and on the right side I want to write this one, 3 to the power t over 9. Okay, what we're gonna do next? We're gonna do another step. So we're gonna multiply both sides to the power 1 over t. Okay, so 1 over t. So as a result, we have t to the power 1 over t equal to 3 to the power t over 9, all raised to the power 1 over t. And right now, of course, we can easily multiply our powers, but basically we can do this without any multiplication because we can cancel this t, and we have only 1 over 9. So in general, we have t to the power 1 over t equal to 3 to the power 1 over 9. So as I said before, we just want to split our constant and our variables, and we already have this expression, our variables on the left side and our constant on the right side. Okay, so I hope you understand this first step. Okay, the next step we're going to do one really interesting trick. We have t to the power 1 over t, so this left side without any changes, but on the right side we can write this 3 to the power 1 over 9. So let's do it. 3 to the power 1 over 9. We're gonna raise this to the power 3, and we're gonna raise this once more to the power 1/3 because we can't change expression. When we cancel it, we have absolutely the same thing. When we cancel 3 and 3, we have absolutely the same thing as in the previous step, yeah? But in general, this is very interesting expression. And right here on the right side, I wanna remember you really interesting rule. I had this rule before. When we have a to the power x raised to the power y, we can write it as a to the power x times y, but in the same way we can write it as a to the power y times x, and we can write it as a to the power y raised to the power x, and every time we have this equal sign. So basically, as you can see, x inside parentheses, y outside, and right here we have the opposite, y inside, x outside. And because of this equal sign, we can say, okay, we can change this by positions. Because of this multiplication, xy equal to yx is the same thing. And I want you to look closely at these parentheses. So we have a to the power x raised to the power y. So we can easily swap this 1 over 9 and 3. Yeah, so let's do it. According to this property, we have this property right here, because everyone knows about maybe this property, but exactly in this case, extremely important for you to learn it. This is extremely interesting part of this property. So we have t to the power 1 over t equal to
3 to the power 3 raised to the power 1 over 9 and raised to the power 1/3. Okay, and right now we can easily simplify real quick our 3 cube. This 3 cube equal to 27. Yeah, so let's do it. So we have t to the power 1 over t equal to 27 to the power 1 over 9 and all raised to the power 1/3. Okay, so after all the steps we have this expression, and I really hope you understand that our last step is to raise this to the power 1/3, but then in other words we just need to multiply it. So we have 27 to the power 1 over 9 times 1/3, and basically we have 27 to the power 1 over 27. Extremely interesting expression. And right now let's write our left side and right side together. So we have t to the power 1 over t equal to 27 to the power 1 over 27. And let's look closely. We have absolutely the same structure on both sides. We have t to the power 1 over t, 27 to the power 1 over 27. These variables need to be the same, and we have the same variables right here. So we have symmetrical expression, and only one case when t is equal to 27. So t is equal to 27 is only one correct root in this case, because when t equal to 27 we have absolutely the same expression, the same value on both sides. But let's check it in the end. Let's check real quick our t equal to 27. So 3 to the power t equal to t to the power 9. So let's check for t equal to 27. So t equal to 27. So what do we have? 3 to the power 27 equal to 27 to the power 9. So basically we have absolutely the same left side, 3 to the power 27, but 27 on the right side let's write as 3 cubed. 3 cubed raised to the power 9, and according to all known property, everyone knows about it. So we have 3 to the power 27 equal to 27. Not like 27. We can write it as 27, but in this case we need to multiply this 3 times 9. So we have 3 to the power 27. Absolutely the same expression on both sides, because we need to prove that our root is absolutely correct. So a few thoughts about this question. So of course we have our answer, t is equal to 27, but in the same way I made this video maybe a few months ago, and I solved this type of question according to Lambert W function. And one really interesting moment, because this is not only one root. Of course, if you're talking about integers, yeah, t equal to 27 is only one integer according to this question. But in general, there is another root t second equal to 1.15, and of course according to this method you can't solve this question for this t second. But as I said before, I made this video like a few months ago, and I solved this part according to Lambert W function. So if you want to see it, you can easily check it on my YouTube channel. I had this video on my YouTube channel, and I solved it for t second equal to 1.15 according to Lambert W function. But this video is about power rules, about these tricks. So that's why I want to show you how can you solve this type of question according to this tricks. And a few thoughts about this exactly according to this method, because this method is not a general method. So if you have, for example, t to the power 7, you can't solve this question like that. We have a lot of different type of question, I guess, like 2 to the power x equal to x to the power 32, 3 to the power t equal to t to the power 9. These both questions we can solve it according to this method. Yeah, we just split it. We have variables and constant, and then this tricky move. So we need to get the same structure and the same constant on both sides. So that's why this method is good, but this is not a general method. So if you had a completely different expression, like 3 to the power t or 2 to the power t or different ones, you need to solve it according to Lambert W function. And according to Lambert W function, you can get these both roots right here. Yeah, we have these both roots in this case. But in general, yeah, you need to choose what option do you prefer, what solution do you prefer. Of course, maybe there are a lot of teachers here, so write your thoughts, write your response in the comments below. What do you think about this method in general? Because a lot of students, they don't like Lambert W function. So maybe you agree with me that this method is also really good. And of course, write your thoughts, write your response, write your notes in the comments below. What do you think about it? And of course, maybe there are a lot of students here, so write your thoughts. What do you like? Maybe Lambert W function or this strongly, I would say, like strongly algebraic method. Yeah, so write your thoughts in the comments below. So thank you for your time, take care of yourself, have a great day, and see you in the next videos.